How to overcome unit testing failures with WiseTester. I just want to thank again our sponsors for continued support of the LIDNUG community. So both Oakweb and Teleric is our primary sponsor, so I want to thank them very much for continuing to support us. Upcoming events in March, we have Bertrand Leroy giving us a tour around Orchard project on the 21st of March. And Orchard is an ASP.NET MVC3 CMS system. It's open source, and it's also the 5th most downloaded project on Codeplex. And we also have Lisa Feigenbaum doing a Visual Studio tips and tricks. This is going to be a hands-on approach. She's actually going to be showcasing an actual application and build it while we see it. And that's on the 24th of March. As usual, all of our sites, of course, they're linked in the news group, our official home, and our unofficial home, LIDNUG.org. There's our calendars, our Twitters, we'll keep up to date with what's going on, and Facebook. And also, if you have any questions, feel free to send an email to info@lidnug.org. Also, as usual, the LIDNUG team are always there to help you out and to give you any feedback or responses or answer any questions you might have. Feel free to catch us in here or on the LinkedIn groups discussion forum, which is very, very popular at the moment. Anyways, I want to head over to Lior Peleg. Lior Peleg is the owner of WiseTester, and I'll be showcasing, as I said, how to overcome those unit test failures with WiseTester. Okay, over to you, Lior.
Okay, hi everyone. Welcome and thank you for joining this webinar. My name is Lior Peleg. Today we are going to introduce an innovative approach to overcome unit test failures. As I said, my name is Lior Peleg. I'm the founder of the WiseTester project. WiseTester is a development tool for .NET developers using unit tests and integration tests in order to test their code, and it helps them to reduce the time they spend on fixing a test which fails. So let's talk a little about the agenda, the main topics we are going to discuss today. We are going to introduce the software regression, and we are going to discuss types of software regressions. Next, we will discuss traditional approaches to handle software regression today. Next, we will talk about common scenarios for test failures, and we will also discuss current approaches to handle regression in automatic tests. After that, we will reach to the main topic of this webinar and present an innovative approach to overcome regression in automatic tests. We will have a demo showing an implementation of this approach, and we will then discuss final best practices of integrating this new approach and the benefits that the development group can gain by adopting this new approach. At the end, hopefully, we will have a session of Q&A. And that's it. Let's start. Okay, so software regression is a software bug that is being introduced after a certain event, most commonly code changes in the application source. For example, let's say that there is a certain application and one of the team members decides to implement a new feature or to do a bug fix, and for that purpose he makes some changes in the application source code. As a result of these code changes, another feature which used to work in a certain way stops functioning as intended. This is one of the most common scenarios for software regression. Another variation of regression is software performance regression. And it is a situation in which the application performs slowly or uses more memory in compared to previous versions. And in performance regression, the application still functions correctly, but there is only a performance degradation. Now, there are several traditional approaches to deliver application versions which are free of regression problems as much as possible. Most of these approaches concentrate in detecting the regression before the application reaches the production and fix these problems. The first approach is to perform manual testing, manual functionality tests by QA engineers before releasing a new application version or application patch. With time, software development groups realize that this is not enough. There is not enough manpower to cover all the scenarios in the application, and they started to write automatic tests. So this is another approach to write automatic regression tests. There are unit tests, integration tests, and GUI tests. Unit testing is a great methodology in which individual units of the application source code are being tested to verify that they function as expected. Integration testing is the phase in which individual software units are combined and tested as a group. So instead of testing small units, we check how multiple software components work together. And in the rest of the presentation, we will mainly concentrate on unit tests and integration tests, but the same concepts can be applied on GUI tests as well. So now we will shortly discuss a scenario in which tests which used to pass suddenly starts to fail. The most common scenarios are changes in the application source code, like we've mentioned earlier. Another common scenario is when the test data is being changed. By saying test data, I refer to input files and reference files or any other type of file which is being used by the test methods in order to test the application. For example, let's say that there are tests which use a large input. They take it from an input file which resides in the memory and also compare the output of the functionality they are testing into a file and compare it to a reference output file to verify that the functionality works as expected. So changes in the testing that data can cause tests to fail. One of the common scenarios is when a developer wants to update a certain input file, which needs to be upgraded to fit some new behavior in the application. And this input file also being used by other tests. So after this change, the other tests start to fail. There are also less common scenarios. A test might fail due to changes in date time. Pretty rare, but it can happen. Also, when the environment of the execution is being changed, tests might fail. For example, if we are running at a machine with low disk space, if the build server which execute the tests have low disk space in some of the executions, this can also cause tests to fail. Another pretty rare scenario, but very painful when it happened, is changes in the order of execution of the tests. It might also cause test failures that will usually won't happen with unit tests, since in real unit testing each unit test should be independent, but this can certainly happen with integration tests, which changes the database or changes the dynamic memory in a way which influence other tests. So the common scenario would be if a certain integration test, if there are two integration tests, test A and test B, and currently the order of execution is executing A and then B, and now they're both passes, but if we change the configurations of the execution order and B suddenly is being executed before A, it might change the state in the database or in the dynamic memory, and by that cause test A to fail. And there are other tests which are being failed randomly. If you are using some randomization in your code, like random algorithms, it might occur. Although it can happen even if you don't use randomization in your code. If, for example, you're using legacy code written in C, C++, or any other unmanaged memory language, tests might fail randomly due to bugs related to memory allocation and so on. So before we continue, I would like to discuss configurations in which development groups integrate automatic tests in their environment. One of them is after completing developing a feature, a sub-feature of a bug fix, there are developers which might execute a small group of relevant tests locally on their machine before committing their changes into the source control repository, since they estimate that their code changes might affect the functionality tested by these tests. Most of the development groups have another configuration. Most of the development groups have their whole automatic tests being executed on a daily basis by a build server, together with each new build. Another configuration, there are development groups which have a very, very large set of unit tests and integration tests, which have an execution time of more than several hours. These groups execute the whole set of unit tests only once a week or once a month, and use a smaller subset of these tests as a subset which is being executed every day. And of course, usually development group will use a combination of these configurations. Okay, of course, now we will discuss current approaches to handle regression in automatic tests. There are methodologies like pair programming, code reviews, and so on, which meant to prevent regression at the first place. But once a regression already occurs, there are usually two approaches to deal with it. The most natural thing to do when a test fails is to debug it in order to find the problem. This works, but it might take a lot of development time. When a developer is being notified that by the build server that a certain test failed during the last build, he first needs to open the debug environment. For some of the project, that means to open the solution containing the tests, which means more time until it is being opened, more CPU consumption. The next step will be to reproduce the problem locally in the developer's machine, namely run the test and verify that it fails the same way it fails on the build server. After reproducing the failure, comes the step of the debugging, and in the best case it only takes minutes of debugging to understand where the problem is. However, in many other cases, debugging the test might take hours until finding the source of the problem. If the developer didn't write the test, but inherited it from another team member, the debugging gets more difficult. Another situation which might make things somewhat complicated is if the problem is related to code changes which were committed by another team member, and this could also make it harder to find the problem. Okay, that is the first approach. Some other approach, there are developers which might try to review the latest changes committed into the source control repository and try to estimate which of the latest changes broke the test, then run the test with and without the change in order to conclude whether it is the one who broke the test. This might save some time, but in many cases will not be suitable. There may be many changes to review between the current build in which the test failed and the last build in which the test passes. As well, behind every change set committed into the source control, there might be many committed source files, so even if the message of the commit looks suspicious, the developer might still not get a good focus on any specific code section which broke the test. Another issue is that the developer spends the time on reviewing these changes without any guarantee that it will actually help him. Not to mention that this approach doesn't help developers who execute their tests before committing their changes into the source control. If the test failed due to new code changes which haven't been committed yet and are waiting to be committed, reviewing the latest changes on the source control log won't help. So, to summarize, in both of the scenarios we've just described, the developer might spend a lot of time until getting to the point where he understands why his test failed. Only then the developer can decide how to solve the problem he found. Which brings us to the main subject of this presentation, some innovative approach to overcome regression in unit tests. So the main concept of this approach is that when a developer gets a notification that his test failed, the notification should come together with the exact code changes that caused the failure, so he can review them before he even starts any debugging. In addition, if these code changes came from the source control, the notification should also come together with the developer who committed these code changes. Regarding the motivation, reviewing the exact code changes which caused the test to fail can give the developer a huge added value when starting to fix the test. In many times, the developer will understand right away how the code changes which broke the test caused the problem, so that it is only left for him to apply the right solution, skipping the exhausting step of debugging the test to find the problem. In other cases, it makes the developer more focused on where to look for the problem. Source control based regression analysis. This is based on a concept which is known in the development community for some time. Let's say, for instance, that a developer is being notified by the build server that one of his tests failed during the latest daily build. In most of the cases, it means that somewhere between the current build in which the test fails and one of the previous builds in which the test passed, there was a commit of the code changes into the source control which caused the test to fail. So the developer can theoretically go through the following process in order to find the problematic commit. After first, verify that the test also fails in the latest version on his local machine, and then iteratively update the working copy on his local machine from the source control repository, each time with the previous version, with the previous revision. In each iteration, he can build the sources and execute the test which failed. He can continue this process until finding the revision in which the test passes. He can then conclude that the change set of the revision in which the test fails for the first time chronologically after it passes is the change set that caused the failure. Of course, no developer will be willing to go through such a manual process each time a test fails, but if he can get it done automatically, it can give him some added value in some of the cases. There are projects which execute their tests per each commit. There are such environments which have the ability to run the tests per each commit, so they also get this benefit. It's a great thing, but it is only suitable for projects where the test execution doesn't take more than, let's say, about 30 minutes. If getting the latest version, build and execute the relevant tests takes more, it might be impossible to execute them per each commit. The advantage of this approach is that it runs the analysis only for tests which fails. Okay, IDE-based regression analysis. Regarding the source control-based analysis, which we have just seen, it is nice, and in some of the cases it can help. However, in many cases it won't be suitable to really give an added value, since the change set which caused the test to fail might contain a lot of source files to review. In these cases, it might be faster to debug the test regularly to find the problem. Moreover, there are cases in which the developer works for several days and on a big feature or part of a feature on his local machine, and after completing the development, he executes the relevant tests to verify that his code changes haven't introduced new problems. If one of his tests fails due to these code changes, the source control based analysis won't help, since all the code changes came from his local machine and there is no reflection of these changes in the source control repository yet. To overcome these two disadvantages, we need to get a better resolution of the code changes by integrating into the IDE and collect information regarding the changes that the developer makes during his development sessions. We can create a timeline of source changes data. If we can get snapshots of our source code often enough, we can then use this data and apply the same process described in the previous section in order to find the exact code changes which caused the unit test to fail in a much better resolution. What I'm going to do now is to share my desktop. And we will have a demo of these two variations. Okay, for this demo we will use Visual Studio 2008, and we will use NUnit as the unit testing framework and SVN as the source control, together with Tortoise SVN. Let's have a quick introduction to the following sample solution. It contains a data structures project with data structures, some manipulations project with manipulation on these data structures, and a test project to test the functionality. The test project contains both integration tests and some unit tests as well. In this example, our developer uses a batch file in order to execute the tests, all the tests in the test project. And we can see that currently all the tests passes. Okay. The first scenario I would like to focus on in this session is a scenario in which the developer works regularly, and in some point he wishes to get the latest version from the source control in order to sync with the other team members. Okay, we can see that there are several changes. We will now build the solution. So normally the build server should execute the tests, but for this demo, let's just rerun the tests we executed earlier. And now we can see that as a result of getting the latest changes, 2 of our tests fail. So like we explained earlier, we can apply one of the traditional approaches, a debug session, or reviewing the latest changes and try to guess the change set which caused each one of these tests to fail. But let's do some regression analysis. Let's start with this test. We will use the WiseTester for this purpose, and we will execute the source control-based regression analysis. Meanwhile, the developer can continue his work. And before we continue, it's important to mention that this is not the best practice of executing the analysis. The best practice to do so is to integrate the source control-based regression analysis into the daily build operation, so that the developer won't have to spend time after he's being notified that the test failed. Okay, the analysis is completed. We can see that the revision which broke the test is 18, and the author is John. We can check it, check the revision and to review it. Okay, that looks pretty good. Only one file, and we can also see that it doesn't contain many changes. It only contains one change. And in this case, by looking at it, it is pretty clear what happened. John tried to do some code enhancement and to replace this kludgy getValue method by using an indexer, but when he deleted this line and retyped it, he accidentally used the equals operator instead of using not equal. This is a good example where source control based analysis is very beneficial. We can just go to the place in the code and do the fix. Here it is. Great. We can see that now the test which used to fail is fixed. And now let's analyze the other one, test matrix operations. Okay, the analysis is completed, and we can see that the commit which caused this test to fail is in revision 21. But the message doesn't look too optimistic. We can see that from the message that it is a massive check-in, which contains infrastructure changes. Let's review it in the source control. Okay, we can see that there are many files to review, and if we try to review one of them, we can see that there are many code changes in this commit. I think that most of the developers would prefer a debug session rather than start reviewing all these code changes. It's too much. And this is exactly why IDE-oriented analysis is required. Now we will demo an IDE-based regression analysis, and we will use the same sample solution from the previous example. But now we are going to have a development session, a regular development session in which we make some code changes in the application source code ourselves. Now, this solution is being monitored by the WiseTester. So the changes we do during our development sessions are being monitored and stored for later usage. Let's start our session. First, let's verify that the test passes. Reminding you, this is the same sample solution, but before the changes. Okay, we can see that all the tests are being passed successfully. Now let's have a common development session. We start by removing the code duplication, this code duplication. Next, let's simplify our code by using an indexer. We will replace these get and set methods by just using an indexer. Okay, next we will change the default value in the matrix constructor from 1 to 0. And as our last change, let's say we want to add a message to our exception. Not such a good practice, but okay. Now let's build. Okay, build passes successfully. And now we will run the tests before committing the changes into the source control. We can see that the test matrix operations is now failed, and we know that it relates to one of the changes we have just done. But because of reasons we explained earlier, we cannot use the source control based analysis. So now we will see how to use the ID-oriented test analysis. Okay, we can see that the analysis is over. The code changes which caused the unit test to fail has been detected, and results are saved to disk. What we see here is the revision before the problematic change, and the revision after the problematic change. And we can use a diff tool like WinRange. And we can see that the analysis detected the exact code line, the change in the exact code line which caused the test to fail. Please notice that we haven't saved the file while typing, and we didn't build in the middle. And this is the strength of this analysis. It can find the exact code line or the exact code snippet which caused the test to fail. Of course, now the developer can decide whether this is whether it is a bug or enhancement in the behavior, and now we need to update the test. But he doesn't need to, at least at this case, he doesn't need to debug in order to find the change which caused the test to fail. Let's verify that it indeed works. Great, now all the tests are being passed successfully. And we can go back to the presentation. To discuss some best practices of integrating this regression analysis, we can integrate the source control based regression analysis into the daily build. In this way, the developer gets the notification that his test failed in the latest build, together with the change set which caused the failure. And for those developers who have their ID monitored, we can then run the IDE-based regression analysis in order to get a better resolution inside that change set. So if you got a notification that your test failed, together with the change set which broke your test, if it is you, then you can run the IDE-based regression analysis on your machine because you are the one who broke it. And if it's another developer, he can execute the IDE-based analysis on his machine and let you know the exact code snippet or code changes which caused the failure in a much better resolution. Briefly describe the advantages and disadvantages of each one of these variations. Source control based regression analysis can detect the problematic code changes being introduced by other team members. This is its advantage, but the resolution is low. It only gives you the change set. And IDE-based regression analysis can point the exact code changes which caused the failure with a very high resolution. However, it can detect problematic code changes being committed by other team members. Those team members will have to execute the analysis on their machine. So these two variations really complete each other. Okay, we can discuss the benefits. The benefits of adopting this approach is mainly save development time. Save development time to all the team members. Some cases in which it can be extremely helpful is overcoming test failures, even if they occur due to code changes committed by other team members, and overcoming test failures in unit tests or integration tests that cover source code inherited from other developers, like legacy code, and overcome failures in heavy unit testing or integration testing, which are being executed in a low frequency. Usually they are more harder to fix because the problematic code changes which caused the failure were committed days ago, sometimes weeks ago. Another benefit is to encourage developers to write more unit tests. That's it. If the audio is fine, we can have a Q&A session.
All right, thanks for that, Lior. Yeah, that was quite an interesting approach to interest analysis. As Lior said, feel free to unmute your mics if you want to, and we can do a bit of Q&A with Lior. Anyways, thank you everybody. Thank you for attending. As usual, this would be recorded and uploaded to our website as soon as possible.